Today we'll be doing the integral from 0 to infinity of x squared divided by ax squared plus b quantity squared dx. And to start off, we will consider the following integral. We will consider the integral from 0 to infinity 1 over ax squared plus b dx, which is equal to the integral from 0 to infinity 1 over the square root of a times x squared plus the square root of b squared dx. And we will let the square root of a times x equal square root of b tangent theta, which means that x equals the square root of b over the square root of a tangent theta, and dx will be the square root of b over the square root of a secant squared theta d theta, and the square root of a times x over the square root of b is the tangent of theta. Solving for theta, we have theta is the arctangent of the square root of a times x over the square root of b, and that also means that theta 1 will end up being 0 and theta 2 will be pi over 2. And the square root of a times x quantity squared plus the square root of b quantity squared will end up simplifying into b secant squared theta. So this integral transforms into the integral from 0 to pi over 2, 1 over b secant squared theta times square root of b over the square root of a secant squared theta d theta. The secant squares end up canceling, and we have the integral from 0 to pi over 2 of the square root of b over b times the square root of a d theta. And we could factor out the constant, so we have the square root of b over b times the square root of a, and then the integral from 0 to pi over 2 of d theta, which will just end up being square root of b over b times the square root of a times pi over 2. And now I will rationalize the denominator and the numerator by a factor of the square root of b. So we're going to have a pi times b over 2b square root of a times b. The b's cancel. And so we have that the integral from 0 to infinity 1 over ax squared plus b dx is equal to pi over 2 times the square root of a b. And now from here, we will differentiate both sides with respect to a. So it means we have that the integral from 0 to infinity, the partial derivative with respect to a, of 1 over ax squared plus b will be pi over 2 the partial derivative with respect to a of 1 over the square root of ab. So now we just have to compute these derivatives now. So we have the integral from 0 to infinity, the partial derivative with respect to a of, we can rewrite this as ax squared plus b to the negative 1 dx equals pi over 2 the derivative with respect to a of ab to the negative 1/2 power. So we now have, this is equal to the integral from 0 to infinity. Taking this derivative, we have negative 1 ax squared plus b to the negative 2, and the derivative with respect to a of ax squared plus b dx is going to be equal to pi over 2 negative 1/2 ab to the negative half minus 1, and the derivative with respect to a of ab. So this is going to be the integral from 0 to infinity negative 1 ax squared plus b to the negative 2. This will end up being x squared dx, which is equal to pi over 2 negative 1/2 ab to the negative 3/2, and it's going to be times b. So simplifying this, we have the integral from 0 to infinity negative x squared divided by ax squared plus b quantity squared dx will end up being negative pi times b over 4ab to the 3/2, which we could write this as negative pi times b over 4 and then the square root of ab cubed. And as you could see, these negatives end up canceling. So this means that the desired integral, the integral from 0 to infinity of x squared divided by ax squared plus b quantity squared dx, will end up being pi times b over 4 and then the square root of ab cubed, provided that a and b are greater than 0. And so this is the final result. Thank you very much for watching.